Problem number 1, day 2 of density. That 0.25 is your density of this. So I go D equals mass divided by volume. I'm looking for the weight. Now, people did get on my nerves, but they got on my case fourth period. Mass versus weight, I use them interchangeably. I'm not the science person here. All right, I use them interchangeably. Well, isn't mass, well, the gravity comes down. Okay, weight, mass, I use same terms for me. So that's what we're looking for here. We're looking for the mass. We just figured out the 0.25 was the density. You got to help me. What's the volume of this container? That's why this is in this unit. What's the volume of the container? All right, so turn it over to somebody else. How can you find the volume of the container here? 21. Quinn, what shape is it again, this container? Okay, so I can use BH or length times width times height because it's rectangular. Go ahead. What do you got for me?
12 times 8.5 times 2.
Yep. Oh, gee. Oh, hold on. I forgot. Hold on. I forgot. We need to check something before we start finding the volume. Does the density match the dimensions? Because if it doesn't, I need to convert. Does the density match the dimensions? What's the density? Pounds per cubic foot. What's the dimensions in? Okay, we're good. Because sometimes that doesn't happen. And you need to change it now. Everyone good there? You need to say, does my density unit match the dimensions of the figure I'm working with? If it doesn't, you got to convert it. So I got feet. We're good. Let's keep rolling. 408 cubic feet for the container. So I go back to my density. 0.25 equals the mass divided by the volume, 408. And then we're good. We're rolling now. Cross multiply. Read the directions for rounding. And I don't need any rounding directions because none are needed here. $102. Look back at your density. What's the weight in pounds? So make sure we put the lbs there. All right. That's street lingo for pounds for some of you kids. All right. So no change needed. No change needed in units. Questions? Also, I just want to mention before we go to the next problem, do I need to see the density formula? No. Some of you guys may just read this and say, I know I got to multiply that 408 by 2.25. Just show that. That's fine. I don't need to see density. But I'm showing you why I'm multiplying. All right? 5. We're going to 5. Skipping over to 5 now. Now we get a little bit tougher because you will notice some change in units. Wow, a lot going on there. This is a good quiz word problem. I straight up come out with the volume for you. You don't even need to find it. You're welcome. You don't even need to find the volume here. 29 cents a kilogram. Density, I even told you the vocabulary term there. Grams per centimeters cubed. All right, stop. Does the density match the volume? Does the density match the volume? Some of you are shaking your head no. Does the density match the volume? What's the density? Grams per centimeter cube. What's your volume in? Cubic centimeters. So we're good. Okay, I know some of you guys are seeing grams. Then all of a sudden we bust out kilograms. We can wait to the end to do that. All right, the only time you need to change at the very beginning of the problem is if your dimensions of the figure do not match the density. Okay? We're all good. I don't care about the weight can be done at the end. Weight can be done at the end and converted. All right, so how much does one of these steel parts weigh? Because if you're going to charge me per kilogram, I better know how much it weighs. 7.95, and for D, the density. How much does it weigh? M, volume. Unlike the last problem, you don't even need to calculate it. It's already 1,015. All right, let's roll. Don't even need to calculate the mass. Paper. Here we go. Mass. Where'd you go? There you are. 8,069.25. What's the mass in here? Go back to your density. What's this in? Grams, right? Grams, because that's what the density was in. Grams, but that does me no good because how are they charging me? Per kilogram. So now we need to convert this to kilograms. How? That's your call. 1 kilogram equals 1,000 grams. That would be something I would give you within the problem. All right, because it's not on your formula sheet. All right. I'm hoping at this point, or by next week anyway, we know what to do with that 1,000. Do I multiply? Do I divide? If you're on the fence, here's the conversion. Make a proportion out of it. Grams, go with grams. Kilograms, I'm trying to figure that out. When you cross multiply, 1,000x equals the 8,069.25. Everyone sees what should I be doing with the 1,000 now, right? Makes it pretty easy if you're unsure to make a proportion. All right, so what do I do with the 1,000? Ellie, going back to you, what do I do with the 1,000?
You divide by 1,000.
Good job. I use it to divide. So I'm going to divide this by 1,000. And now it'll be in kilograms. 8.06925 kilograms. There it is. That's not even done yet. This is how much one solid steel part weighs. That's it. I need 500 at 29 cents a kilogram. How much am I going to pay? Okay, that's the weight of one of them. I need 500 and it's 29 cents a kilogram. I'm just interested in what you want to do next. Because there's two different ways you could go to get to the final answer here. Two different ways. 10, Adam, what's your way? What do you want to do now?
Multiply by 1,000
Why 1,000?
because it's kilograms.
Yeah, I know. We already converted it, though. If I multiply by 1,000, I'm going to be back to grams.
Then multiply by 500.
Okay, I can multiply by 500. Did anybody want to multiply by the money first? You could do that, too. It doesn't matter. You're either going to multiply by 500 or you're going to multiply by 29 cents. You're going to have to do both to get to the final answer. So yeah, let's multiply this by 500. That'll give us the weight of 500 steel parts. And then we'll have to multiply it by our money, which was, again, 29 cents. Okay? The order you do that will not matter because multiplication doesn't matter what order you do it in. And then nearest dollar. $1,170 for my cost. What's up, Quinn?
Is it fine to just multiply by 500 before you convert it?
So the grams?
Yeah.
Yeah. Just don't multiply it by 0.29. But yeah, if you want to stay here with the 8,069 times 500, that'll be 500 parts in grams. Yeah, that's fine. Absolutely. Any other questions or concerns on this one? Another great question. So as you're doing these today, figure out what the density is and make sure it matches your dimensions of the figure first. If it does, keep going. If it doesn't, you got to change the dimensions of your figure. So you guys in class, here we go, number 2. You guys at home, number 2. I'm gonna give you guys a while to work on it, then I'll reveal the final answer up on the board. But you guys in class are gonna call me over when you're confident you have the answer. You guys, and then you guys at home, once, if I don't reveal the answer quick enough, you go on to the next problem, okay? I'll announce when number 2 is being revealed, all right? Please assume that an oak tree is in the shape of a cylinder. If anybody's watching this video at home on a separate day or time, just fast forward it to where I reveal the answer. What's up, sir? All right, let's go. What do you got here? Good. Yep. You guys, don't worry about erasing it. Just round to the nearest whole number. If you already wrote the decimal, leave it. All right, nearest whole number, and then when you think you're ready, call me over again for number 2. Okay, where are we going here? Well, this is circumference, right? And that is 1 point. Yep. Okay, so that's the what though?
Thing.
Okay, so I don't want to use that in my formula because I have what?
Radius.
Okay, so everything looks good, and you might want to multiply those two again. 752 times, because that's the correct volume. You got that correct, so something went wrong. Because look, 752 times that's going to give you 9, right? Okay, so round that and you'd be fine. Okay, keep going, keep going. Okay, a little too big here. Okay, I think I know what we're on. When you did that in your calculator, did you just do 4.5 divided by 2 pi and that's it, right? Okay, because here's what happens, and just for future reference. When you do that, your calculator is going to divide by 2 only, and then it follows order of operation, so it's going to go left to right. 4.5 divided by 2, whatever that is, multiplied by pi. So put that in parentheses if you want to do that, and you're going to get a new number then. Okay, keep rolling, keep rolling. Okay, 3.
Mr. President, I do the same thing I added.
No, you're fine, 'cause
Oh.
you're dividing by pi, right?
No, but I did.
Okay, if you're dividing by 2 pi, it's gotta go in parentheses.
Like the entire thing.
No, like 4.5 divided by parentheses, unless you're using a fraction template, then you don't have to worry about it.
Oh yeah, I did.
All right, yeah, that's fine,
Yeah.
that's the volume right there, you're good.
So did I get the right answer?
Yeah, you're fine, okay, we're good, let's go to 3. Rocking over here today, huh? Good, keep rolling. You're right here? Okay, pi r squared times the height, pi times that squared times 8, right? That's an 8, okay, so that's a little too big though,
That's why I thought something went wrong.
because this should be 0.7. Because you're, okay, here's the issue, right off the bat, here, that's your circumference, not 450.
I tried to convert it to centimeters.
Why? What's in centimeters in this problem?
Oh, I put that in centimeters.
Cubic meter, you're
I
fine,
heard that.
there's no reason to convert.
Oh.
Okay. Okay, where's the volume coming from? Okay, I don't have the R though. What do I have? So I need to use the circumference formula, which is what? Nope, that's not the circumference. Okay, 2 pi r equals 4.5. And then I need to solve for the radius so I can plug it back into the formula. Yep. That's fine, you're good, keep going. You guys at home, here you go, number 2. Yep, give me 1 second. Okay. You multiply something by 4/3, so you got 268, right? And you multiply that by, okay, try that again. Points, okay, here's why. There's the
Oh, I did that last night too.
common mistake, and then you're good. Ooh, boss is rolling. I'm gonna tell you next one though, slow it down a bit, okay? All right, question, somebody had a question at home. Okay, who's got the question at home? Go ahead.
I've read this. It says it has a circumference of 4.5 meters.
Okay.
So I'm just confused on how I got an answer that was 3 times that. What your answer?
Okay, well, you had to find the radius using the circumference, correct? Or the diameter.
Oh.
You solve for
Oh, I think
diameter.
I found the surface. I think I found I don't know what I did. I think I found the surface area.
You gotta do C equals pi d.
Yeah.
Solve for the diameter. Solve for the diameter, cut it in half, and then there's your radius, Chris, all right?
Sorry, I must have just done the wrong thing.
All right, that's fine. Let me know if you still got questions. Okay, something. Okay, ready? Yep, because your answer is double what it should be. What happened? What's gotta happen? Yep. Dog. Good. 3. Yep, good. 9 cents. Yep, and then that goes to number 3. All right, we're good. Take your time on the next one, it's no joke. Take your time on the next one. Yep, you're good. Next one.
Wait. Is that it?
We're off by a little bit. We're in the 16,000s, which is correct. So volume 1/2. 62.4.
Oh. Oh, yeah.
You're off by a little less than that.
Yeah.
16,336.
Yep.
All right, you guys at home, number 3 coming at you. Okay. So the next one.
I'm gonna do some numbers.
All right, let's see here. 670. Let's see, just make sure it's right at the beginning. The volume is. Okay, here's the thing. Everyone's driving me nuts with this. You are given this formula on the sheet. It's pi r cubed. Look at the sheet.
Can I go get a drink?
Sure. Take your time, man. Think we're ready for this one?
I think so.
Let's go. Majority of you are on the Big Al kickboxing question. Just so we start off on the right foot. Please notice the density at the end of the problem is 95.46 pounds per cubic foot. And take a look at that base. They are not in feet. So you may want to change those inches to feet before you start, because this is a case where your density does not match the dimensions. up, Sean. Okay, let's get the big Al. Number 4 for you guys at home. Number 4 up on the board, and then it's Big Al time. Okay. If any of you guys get stuck, let me know. I'll push you a little bit. All right, let's go. Here we go. All right, what do you got?
How am I supposed to find the bag?
Well, we don't fill it up though. I know this whole thing without sand is 270. I'm gonna put sand in 85% of the base. So basically what I have to do here is 270 plus the weight of the sand I put in here. And that's basically your big job here,
Okay.
is what's the weight of the sand I put in there. Okay? Yeah, this, I'm not doing anything with that, that's staying empty. Okay? Okay, we are off here. Okay, so I got that. I got the conversions, got it. Pi, and that's 1 2/3 cut in half, right? Square times that. Okay, I got your volume. Okay, volume. Okay, here's the thing. You don't take 85% of your density. I'm filling that up 85%. So what do I want to take 85% of? There you go. Okay, and then see what happens now. Because your volume's good.
How do I get, like, how do I write this in here?
What I would probably do, unless, you probably don't want to write that whole thing, hit your math button again and turn it back into a fraction. Just choice 1 and it'll turn it back. So you can write it as 5/3.
Okay.
Okay, but remember that's the diameter, right?
Mhm.
Okay,
So should I divide it by 2?
well, if you're gonna plug it into the formula, because that's R.
Or
Uh-huh. All right, Nate, what do you got for me?
I think I'm it.
Okay, talk to me here. Yeah. Yeah. Okay, the only thing I don't like is you rounding that to 1.7. All right, you should have just left it as, or changed it, watch, 20 divided by 12, you got that crazy thing, right? Divided by 2, because that's the diameter. So that's what your radius is, right? And see, 0.8333, and now you got 0.85, that's a big difference. So, and I know it's crappy writing all that out, so instead, hit your math button and turn it back into a fraction, and just write 5/6 squared instead, okay, and you'll get a more precise one. Now, when you get here now, whenever that new volume is, remember, that's the volume of this whole thing, but I'm not filling the whole thing with sand. 85% of it, so I need 85% of that volume, that's what's gonna go in here, and that'll give you the weight of the sand. Yep. That's, okay, that's the volume of the sand, right? And you're multiplying that by 95.4. Okay, what's the issue?
I should do that.
Yeah, you're fine. Now remember, that'll end up, that's gonna give you the mass of the sand that's in there. And I need the weight of the entire thing. Okay, just not the sand. So that's the sand weight, not the weight of the entire thing. So how are you gonna finish this up? Correct, and you're good. No. So let's see here. Okay, volume, where's your height? Pi r squared times the height. Will you use that darn formula for me? Okay, it's, you're giving it. You're giving it. Use it. You're right. Ooh, what's going on, boss? How you were just rolling
I did something.
and then a
wrong.
screeching halt.
I know.
Okay, well, let's start here, right? They're only gonna fill it 6 inches from the top, so now I can't use 4 here,
Okay, yeah, so you
right?
have
So
to,
you use 3.5 in your formula?
yeah.
So you did 30 times 15 times 3.5.
Yeah.
Okay, and then here you did pi
Well,
12 squared
I
times,
converted it first.
why? Why'd you convert?
Didn't you have to change the dimensions? Or no?
No, why?
Oh, I don't know.
This was the only thing in inches,
Oh, okay,
so that's half a foot.
alright,
So why change then you're going back and forth again.
yeah,
You're making it a lot of work.
okay.
You see what I mean?
I probably messed up there then. 'Cause
So
I
you
like,
keep it in feet, because look, that's what your conversion said, feet,
Alright.
cubic feet, right?
okay,
So the only thing that needed to be converted was the 6 inches, which really means off the deep part, the depth of everything, you're just cutting off a half a foot, okay?
right, I probably just did too much and
Yeah.
messed up somewhere.
There you go. Okay, that's how much the weight of the sand is. Because look, that was the density of the sand, right? So that's how you're finding the mass of the sand. We're looking for the mass of this whole thing. So the sand's in there at 266. What else do you have to add to it? Okay. And then you're good.
I think I messed up, because for the weight of the sand, I can't 30.
Yeah, yep. Okay, so, here's the thing, right off the beginning, right? What's the density? 95.46, keep going.
Per cubic foot.
That's not what he figures in.
Yeah, but then I try to convert it, and I got 400.
We'll convert what though?
Uh,
You gotta convert it now. You can't convert it here's why you can't convert it at the end, because 12 cubic inches is not equal to 1 cubic foot. It's different. Okay, so that's why I say do it at the beginning.
Alright.
Okay, have a good weekend, guys. Answers are on Classroom, but not the work, so you're gonna have to show me the work.
There's a 536 for the.
Yes, sir. Good job, everybody. Needed a day like that.
You got it.